Okay, guys, we're talking titrations. And I'm doing this before you try to watch my videos that I do with my daughter about mixing acids and bases together. Um, so it's an acid-base reaction. And the goal here is it's a little bit of acid-base and it's a little bit of stoichiometry. And the goal when you titrate is you're trying to take either an acid or a base. Well, in this example, I'll talk about an acid, where you've got a volume of it and you know the volume and you know the molarity, and then you've got a sample, in this case the base, and you either know the volume and you don't know the molarity, or you know the molarity but you're not sure how much you have, and you want to knock out your sample and you want moles to equal moles. And so you mix them together and you use an indicator, or you might have a pH probe, but you have some way of telling that you know when the reaction is perfectly mixed so that all of your acid has knocked out all of your base. So typically you use an indicator so that when your reaction is perfectly mixed and moles have knocked out moles, moles of acid have knocked out moles of base, or moles of base have knocked out moles of acid, that you get a color change. Um, so when you get that color change, you know to stop. So you got to be titrating very carefully. And at that point, you can then go calculate, you go run numbers and say, okay, I know I had an acid that was this strong, was this molarity. I know I added this volume, so molarity times volume gives me moles. Oh, I know I had to have this many moles of base, and then I can go run those numbers based off molarity and volume to figure out what variable I was missing. Um, it's important to note that when you mix and we say neutralize, neutralize implies that you're going to wind up with a pH of 7, and sometimes you do. When you mix a strong acid and strong base, you do wind up with a pH of 7 because you get water and a salt like sodium chloride or potassium chloride that doesn't mess with the pH of your solution. If you mix a weak acid and a strong base, when you get your products, you get water, but one of your products then is going to be a weak base, and that's going to do something to your solution. So when you neutralize this combination, you're going to have a pH above 7, or if you mix a strong acid with a weak base, even when you mix it 1-to-1 and you perfectly knock everything out, oh, strong acid plus weak base, you're going to make water and a weak acid, so your pH when you neutralize isn't 7, it's actually a little bit below 7. So don't get fooled when it says you do a titration and you neutralize. It's not always neutral pH 7. Neutralize just means moles of acid have knocked out moles of base, or moles of base have knocked out moles of acid. So just get used to that term. Okay? So here's a problem. And again, this is to get you used to the lab problem that I set up and do with my daughter. So you've got nitric acid, which is a strong acid, and lithium hydroxide, which is a strong base. So when you mix them together, you get water and lithium nitrate. Oh, lithium just makes Li plus, nitrate makes NO3 minus. It doesn't do anything to your solution. So this is going to be a pH of 7 when it's neutralized. So you got an acid of 0.00334 molar, and you've got 75 milliliters of a base sitting in a beaker. You add an indicator to your base, and when you neutralize it, you add some acid from your burette and you drip it in there. And when you get the color change, it turns out you added 32 milliliters of your acid. You need to figure out what the molarity of that base is. How are you going to do it? Well, it turns out there's about 2 ways to do it. I'm going to show you the quick and dirty way, And you can do this, and it doesn't show you that you've really understood anything. And then I'm going to show you the better way to do it. Okay? The first way to do it is to say, look, the molarity of the acid and the volume of my acid is going to equal the molarity of my base and the volume of my base. Because molarity times volume equals moles. Molarity times volume equals moles. This doesn't show you that you actually have to understand anything. Oh, well, 0.0034 times 32 equals 75 times the molarity. Oh, well, divide each side by 75. And you could just plug and chug and not really understand anything and get a molarity that's equal to 0.0015 molar. And it's actually 0.0014. It was like 146 or 145 and you had to round up. Okay, that doesn't really show you that you understand anything, though. It will get you the right answer. I'll show you the better way. Well, let's take your acid for a second. Well, molarity equals moles over volume. So I know if I do molarity times volume, I'm going to get moles of acid that I added. Okay, well, 0.0034 molar. My volume in liters, 0.032 liters, is going to give me moles. Oh, well, when I do that, that's 1.088 times 10 to the minus fourth moles of acid. Well, then I say, wait a minute. It's a one-to-one reaction. Moles of acid equals moles of base. Okay, well then these two things have to be equal moles. So let me do molarity moles in volume here. Oh, well, I've got a volume. I just found moles. Let me find molarity. Oh, well, I've got M. I know I need this many moles of base, and I know I had that many milliliters of base. Oh, well, that's 0.075 liters of base. Let me calculate the molarity. Moles divided by liters, 0.0015 molar. And this way, when you do it, you're not just plugging numbers into a formula and saying, oh yeah, MV equals MV. You're saying, wait a minute, I understand how the equation is related to each other. You're actually doing a little bit of stoich and saying moles equal moles. I'll show you a second example, and we're good to go.